Alrighty. My name is Josh Hill. As I was introduced, I'm the lead analyst for the Institute for the Study of Violent Groups, and today we're going to be talking to you about modeling terrorism culpability. We're sort of following the classic law enforcement or military mode of presentations. We're going to tell you what we're going to tell you, and then we're going to tell it to you, and then we're going to tell you what we just told you. So, in terms of an overview, this gives you a pretty good idea of what's going to be covered in the presentation. First, we're going to talk a little bit about culpability and terrorism generally. We're going to talk about some previous research that's been done on culpability specifically, with a focus on a couple of researchers from my institute, as well as some from Rice University who are working on the problem. Also, we're going to talk a little bit about why we chose the data set we chose in terms of terrorism in the Philippines, and give you an overview of the data. Then we used random forests, which I'm sure you're all familiar with, to a certain degree here. So we're going to justify sort of why we thought random forest would be a good idea as compared to previous approaches. And we also compared it to three others: CART, multinomial logistic regression, and naive Bayes. And we came to some interesting results, and we have some directions for future research. So to start with, as everybody here I'm sure knows, post-September 11th, it's well recognized that terrorism is one of the major problems facing the United States and the world today. Regional conflicts are very complex and getting more so. We can see that in specific conflicts, not only in Iraq, which actually seems to be getting less complex, fortunately, but in Afghanistan and Pakistan, as well as other places. Groups seem to proliferate, and we're never really sure who is doing what, and it's become this great problem for us to solve. In addition, groups have been intermingling with one another. Everybody is familiar with Al-Qaeda, but Al-Qaeda is now sort of this amalgamous movement that we talk about, and one of the things that we've noticed are groups like, for instance, the GSPC in Northern Africa have transformed and have started self-identifying with those movements. They're now called Al-Qaeda in the land of the Islamic Maghreb. And so differentiating amongst these separate entities is fairly difficult. In addition, since 2001 particularly, partially through better tracking of incidents and partially just through an increase in conflict worldwide, there's been an incredible increase in the number of attacks in the area of over doubling. I have a quote here from Bruce Hoffman. He's one of sort of the sages of terrorism research. And he said that in no area is the intelligence lacuna more acute than in Iraq, than in the determination of insurgent identity and numbers, two of the most basic criteria. And we would argue that, he said this in 2006, that even before then and definitely since, this has been more so now applies to terrorism worldwide. Talk to you a little bit about culpability and the way that we conceive of the problem. As I said, it's increasingly difficult to determine who is responsibility, what group particularly, is responsibility for an incident when there's no claim. Most of the time, particularly pre-2001, but even for a while afterwards, there tended to be relatively high rates of claims for attacks, over 50% usually. Now we're seeing fewer and fewer, making it more and more difficult to determine which groups are the ones that need to be targeted most, the most active, etc. Historically, the way we've determined culpability for unclaimed attacks, our intelligence and defense agencies, and to a lesser extent law enforcement agencies, have used analytical tradecraft. And what this basically means is that they do three things primarily. They have an extensive investigation. This is sort of more of the classic law enforcement investigation, even within military circles, where they track down leads, they interview people, and they get information to apply to the problem of who done it. The second is they have forensic matching of weapons and explosives. This allows you to determine a group's MO. If a group uses the same type of explosive repeatedly, and you find that at the scene of an incident, you may be inclined to believe that that group conducted the attack. And then finally, there's probably the most used, especially when it's difficult to get somebody on the ground, there's expertise-based estimates of culpability. Yes, sir. I think that it's probably conflict dependent. Sometimes there's an argument to be made, particularly in Southeast Asia, that it's the acts have become more criminal in nature than they are terroristic. So claiming responsibility doesn't really serve a purpose because you're not really making a political statement anymore. In other conflicts, they're aware that we particularly the United States, but governments all over the world, utilize sort of general patterns of attacks to target appropriate groups to try and reduce them. So if you're conducting a series of attacks, not claiming half of them maybe makes you half as accessible to whomever's trying to stop you. So that's a speculation, but I think it's probably fairly accurate. And so the expertise-based estimates of culpability are like detectives in a way, and we do come at this from a law enforcement perspective, being from myself from a Department of Criminal Justice. And so this is the idea that people build up a corpus of knowledge about groups, individuals, and their activities, and they're able to successfully gauge who is engaging in what activities, and sort of solving the crime, or in this case, terrorist incident in the classic sense, based on intuition, but also based on the two previous things, the elements of the investigation and any type of forensic matching. This has been anecdotally successful. Of course, it's extremely difficult to test whether this is successful empirically, because most government organizations don't want to tell you, one, what they're working on, and two, their error rate if they know it. So it's difficult to get data that lets you know when they say, yes, this is the group and they were right, or no, it's not the group and they were wrong, for instance. In addition, there is a problem that these expertise-based methods are susceptible to several forms of bias. The first one is if there's making all kinds of noises. The first one is if there is frequent attacks in a given location, almost always carried about by a certain group, the obvious assumption is that that group is responsible for the given attack. This may not be the case, depending on other confounding variables that the researcher may or may not know about, or the investigator, I should say. And so it behooves us to look at other techniques to assist analysts in finding the question of who did a given attack. So with that said, there's been some previous research in this area. It was particularly presented as an analytical challenge by Daniel Mabry, who worked on it in his dissertation in 2006. His research, in turn, was based on an initial framework proposed by Chris Hale in 2005 to test the effectiveness of open source data collection developed by Richard Ward. And this eventually developed into ISVG. I'll talk a little bit about that in a moment. But here it's important to note that Dr. Hale's research was aimed at empirical validation of the usefulness of open source data, not developing a good technique for assessing culpability, but it did serve as what has become to be a research framework for the rest of us. He used chi-squared automatic interaction detection to determine factors that predict culpability, particularly different variables that are important in determining culpability. Daniel Mabry proposed several analytical scenarios that I'll talk about in just one second, and utilized both classical statistical techniques and machine learning techniques to examine the problem of culpability. And what he was primarily doing was trying to identify which was more successful, the machine learning techniques or the classical statistical techniques in terms of prediction of culpability. Generally speaking, the learning models outperform the traditional statistical techniques, but success of the classification for culpability was different across different conflicts. So, for instance, his analytical scenarios consisted of Iraq, where he dichotomized the dependent variable as al-Qaeda or not al-Qaeda. He looked at Israel-Palestine, where he looked at, I believe it was Hamas, the PLO, and maybe two other organizations, where he determined that it was much more difficult to predict culpability than it was in Iraq. He was generally pretty successful in Iraq, high 80% correct classification. And he looked at Afghanistan, and the results were also not as good as Iraq, which brings us now to Graham et al. Graham and a group of other researchers at Rice University expanded the classification of culpability by using a global data set of terrorist activity. It went from 2002 to 2007, provided by the Institute for the Study of Violent Groups. They went about it in a slightly different way than everybody else had. Number one, they were using a global data set, which was a much larger corpus of data than anybody else had used previously.